Hi students, in this exercise we will learn how to use grids to edit alignment in Civil 3D, and we will also verify that curves are suitable for the design, and later we will look at component level editing in the end of this exercise. Just open 607 alignment editing drawing. When you will open this drawing, you will see something like this, and in the prospector tab, expand the alignment and then expand centerline alignment. If it is not expanded, then right click on the row D and select zoom to if the alignment is not within view. It will zoom to your alignment, so you can make confirm here. It is our road D. Okay, and we are going to configure these curves using gripping tool. Now zoom into the first curve of the road D, which is nearly 300, station 300, and this curve was inserted in a previous exercise using the default setting and does not match the guiding polyline well. If the warning symbol is in the way after zooming in, please use the region command to update the size of warning symbol. So you can just region, but then you will see it will minimize like this. Then select the row D alignment to activate the grips. You can see we have some grips on the whole alignment. Now select the triangular grip here. Okay, when you will hold your cursor, it will tick when it will get red, and use the midpoint of snap to select it on the original polyline. Here you can see it is the midpoint of the polyline arc, and when the triangular grip is used, the radius is changed without changing the PI. So now we have not here any yellow exclamation marks, which means that our design criteria has been filled for this curve. So we will keep open this drawing for the next part of this exercise. Now when you are designing to meet jurisdictional standards, one of the most important elements is meeting curve radius requirements. It's easy to work an alignment in a tabular view, verifying that the design meets the criteria. So in this part we will verify that our curves are suitable for the design or not. So continue in the drawing from previous step. Now zoom to the row D again, row D alignment, and select it to activate the alignment contextual tab. From the alignment contextual tab, modify panel, choose geometry editor. You can also access the same location by selecting the alignment and right click, and from the context menu selecting editing alignment geometry tool like this. So the alignment layout tools bar open. Now select the alignment grid view tool here. Panorama appears with all the elements of the alignment listed along the left here. Now you can click into many of the fields to modify their values You can use the support bar along the bottom to review the properties of the alignment if necessary. Note that the column can be resized like this, as well as toggle off by right clicking the column header. The segment selected in the alignment grid view is also highlighted. You can see here in the model, which can also make identify the segment easier. Note that the design check failure indication that are shown on the plan also appear in the table here with yellow exclamation mark. Here is one more thing which I want to discuss with you: creating and saving custom panorama views. If you want to save any custom views of this panorama, then how can you do that? If you right click column heading in panorama like this and select the customize column option at the bottom of the menu, you will see at the bottom of the menu customize column. You are just click here and you are presented with the customize column dialog box. These dialogs allow you to set up any number of column views such as road design or stack out to show a set of different columns. These views can be saved allowing you to switch between views easily. So for now we will keep same as default, and for now change the radius value for the segment 4 45.72 to 121.92 and then press enter. Click now the close button. You will notice that the panorama window there is no green check mark here to accept the changes. So to dismiss panorama and then close the alignment layout tools toolbar. So we have done changes for the next curve, and now we will also open with the same drawing for the next part of this exercise. Actually this exercise has 3 parts: grip editing, tabular, panorama editing, and now we will explore component level editing. Panorama allows for quick and easy review of design and for precise data entry if required. Grip editing is commonly used to place the line and curve of an alignment in an approximate working location, but then you use the tabular view in panorama to make the values more reasonable. For example, to change a radius of 292.56 to 300, which is round figure. Also note that for this part of the exercise, when you change the radius, the violation of for the design checks were cleared for the curves, providing feedback that you meet design requirement. So once an alignment gets more complicated, the tabular view in panorama can be hard to navigate, and deciphering which element is which can be difficult. So in this case, reviewing individual elements by picking them on screen can be easier by component level editing. So continue in the drawing from the previous part. Zoom to the road D alignment and select it to activate the contextual alignment tab if it is not still active from the previous step. If the alignment layout toolbar row D is not still open like this, then from the previous exercise, previous part, from the alignment contextual tab, you can open geometry detail tool from here also. So select the sub entity editor tool for now here to open the alignment layout parameters dialog for the road D. Okay, each line, arc, a spiral member of the alignment is referred to as a sub-entity. The sub-entity editor allows you to select any segment member, its properties in the alignment layout parameters dialog. So select the pick sub-entity here on the alignment layout toolbar. Now pick the curve that begins near the 560 on this alignment to display its properties in the alignment layout parameter dialog box. Notice that the tangency constraint values here reports constraint on both sides free. Now change parameter constraint lock to the false, and you will notice that this will enable the ability to set many of the values that previously were grayed out and could not be set. So changing parameter constraint lock to the original status, change the value in the radius 53.34 and press enter. If I zoom out, you will notice this value is too far from the original design intent from here. You will reinvestigate the tangency constraint in the next steps. So change the value in the field for now 60.96. And again watch the update here. This value is closer to the design and is acceptable despite being less than the minimum radius for the design speed. So now close alignment layout parameter dialog and alignment tools toolbar. Notice that the stationing updates. So you can keep open this time for the next exercise, or I will also put another drawing which you can open for the next exercise by using the alignment layout parameter dialog. We can concisely review all the individual parameters of a component in each of the editing method discussed so far. We have modified the alignment elements that were already in place. We will look at how to change the makeup of the alignment itself, not just the values driving it. But first, let's look in the next exercise at some of the constraints of understanding how they work. So stay tuned for the next exercise.